video is about something that I dubbed the Big One Theory. In this video, I'm going to tell you what the Big One Theory is. We're going to look at the different forms that the number 1 takes, and we're going to look at using 1 to get a common denominator, and there'll be a few other Big One Theory uses at the end of the video that I'll elaborate more on in the next video, or in future videos. The Big One Theory is the idea that the number 1 comes in many different forms. It's not just the number 1. And you can use those forms to change parts of equations and still preserve the value of whatever's happening on that side of the equation. It's used in getting common denominators and simplifying fractions and solving equations and rationalizing denominators and in a whole bunch of other things in mathematics. So to understand the Big One Theory, you have to understand that 1 comes in a lot of different forms. When I was teaching, I would tell my students that the number 1 is like a big spy because it can disguise himself as all sorts of other things. You obviously have the basic numeral 1, and that's what most people think of when they think of 1. But 1 can also be any number with an exponent of 0. And I've gone over that in other videos. Here's a basic understanding of why anything to the 0 power is 1. And if you're more interested in that, then I will do another video on that. We're looking at fractions though. And any fraction with a numerator and a denominator that are equal, that's when you get 1, such as x over x, or 1 over 1, or 2 over 2, or 10 over 10. So if we take half, when we multiply it by 1 over 1, well, you'd multiply the numerator times the numerator and the denominator times the denominator because that's how you multiply fractions, and you still get 1/2. And if I do half times 2 over 2, one thing I know about those two answers, half and 2/4, is that they are equal. Why? Because I multiplied by 1. So I did half times 1 over 1, which is equal to 1. And then 2 over 2 is also equal to 1. So half times 2 over 2 is just like taking half times 1, which gives you 2 over 4. And then if I do the same thing to half that I do with this half, if I multiply 1 over 1 by half and 2 over 2 by half, and 1 over 1 and 2 over 2 are both equal to 1, then it means that the results are also equal. 1/2 is equal to 2/4. They're just different forms of the same fraction. And this understanding also goes into when you are doing algebra. And so if you have x plus 2 over x plus 2, it's equal to 1. So when you need to get denominators that are in the form of binomials or trinomials or quadratics, you can think of whenever you're getting your denominators the same so you can add them. It's the same idea as what we're doing when we are adding and subtracting regular fractions. And then if you're thinking about square roots and you have to rationalize the denominator because you can't have a square root or a radical in the denominator. So you multiply it by itself over itself. Because any fraction that has a numerator and a denominator that are equal, that means it's equal to 1. And I say equal and not the same because there are uses when you have the top number equal to the bottom number but not the same. And I'm trying to think of a good example of that. So if I have 1 plus 1 in the numerator and I have 2 in the denominator, that's also equal to 1 because the result of the top is the same as what the bottom is. Now we're going to use the Big One Theory to get common denominators. And in order to do this, you have to understand that we're going to be using the multiplicative identity. The multiplicative identity simply states that anything times 1 is itself. And when you understand that, then you understand the entirety of the Big One Theory. So here's an example. If I have 1/2 plus 3/4, I can't add that as it is, but I can use the multiplicative identity and multiply one of the fractions by 1 so that they then do have the same denominator. Chose 2 over 2, multiply numerator times numerator, denominator times denominator. Then the first fraction changes forms from 1/2 to 2/4, which is what I need because I need denominators that are the same. So now I have 2/4 plus 3/4, which 2 plus 3 is 5, so you have 5/4. This is the basic idea of using the Big One Theory. Here's one, 4/9 plus 4/11. They don't have a common denominator, but we do look at the denominators. So I have a denominator of 9 and a denominator of 11. We need them to be the same denominator. 9 can't multiply to make 11 like 2 could multiply to make 4 in the first example. So what do? Well, you're going to use those two denominators to make a denominator of 99. So you're going to multiply those two denominators together. So I use the 11 to make the first form of the number 1 in 11 over 11. I started out teaching saying you multiply the top by the same thing you multiply the bottom with. Well, kids would forget, what am I doing and why it seems so random to them. When you put it in this format, that you're multiplying by 11 over 11 because that is the number 1, it makes it so much easier for them to remember. And I did make them write the parentheses and the numerator and the denominator being the same for the first several times we practiced it. And by several, I mean probably 20 or 30. Once they write it down that many times, then they might be able to do some of it in their head, but I always make them write it for the first several times that we practice. But as you can see, then I'm multiplying 4/9 by 1, which is going to give me another form of the number 4/9, and it'll be the same value as 4/9. It'll be equal to it. So 11 times 11 is 99, and 11 times 4 is 44. Now we do the same thing, but we use the 9 to create the 1, and so we have 9 over 9, which is equal to 1, and then we do the same thing, denominator times denominator, numerator times numerator, and then you have your fractions in a form which can be added because their denominators are the same. You have 44 plus 36, which gives you 80. 80 over 99. Let's look at a different example, because that example, there is, when you multiply 9 and 11, that's the closest common factor that or common multiple that they have. What if you have numbers like 12 and 15 that have actually a closer common multiple than just multiplying them together? Well, you can do it in which you multiply 12 times 15 and get your common denominator. So it would work like this. Your 12 over 12 is your number 1, and then 7/15 becomes 84 over 180 because you're multiplying your numerators and your denominators, and then you use the 15 to get the second number 1 to multiply the second fraction by 1 and get it in a form over 180. And you have 84 over 180 plus 75 over 180, which gives you 159 over 180. When you have fractions with numerators and denominators that are that large, it's difficult sometimes to tell if they can be simplified. So this one can be simplified, and you actually use a form of the number 1 to simplify it. Both the top and the bottom are divisible by 3. So notice I'm not putting a division sign next to the numerator and a division sign next to the denominator. I'm saying I'm dividing by 3 over 3. 3 over 3 is 1. So I'm dividing by 1, which is another form of the multiplicative identity. You can multiply by 1 or you can divide by 1, and it's not going to change the value. In the case of fractions, it will change the form. 159 divided by 3 is 53, and 180 divided by 3 is 60. Well, is there a way to do this in which you don't use the two denominators multiplied together, but you use smaller common multiple of the two denominators? And yes, there is. And I know if you're a math teacher, you already know this. So let's take a look at 7/15 plus 5/12 again. But this time, let's compare our denominators. And in this next part, you have to know your multiplication facts. Having them memorized makes this part so much easier than anything else. You might not have your 15s memorized, but you can add 15 by adding 10 and adding 5, which is easy. So 15 times 1 is 15. We already know that 12 does not go into 15. So we're going to then take the larger of the two, which is 15, and look at its next multiple. Does 12 go into 30? Well, if you know your multiplication facts, then you know that 30 is not a multiple of 12. So then you look at 15 times 3, and that's 45. Does 12 go into 45? Again, no. 12 goes into 48, not 45. The next multiple of 15 is 60. 12 does go into 60 5 times. So 15 times 4 is 60, and 12 times 5 is 60. We're going to use those two multiplication facts to create our ones, in this case, to change our denominators. So in the case of 15, so the first denominator, 7/15, we're going to use the 4 to change the 15. So I make the 1 out of 4/4. Multiplying 4 times 15, you get 60, and 4 times 7 is 28. And then I'm going to use the 5 to create the form of the number 1 for 5/12. 5 times 12 is also 60, and 5 times 5 is 25. 28 plus 25 is 53, and there you have the simplified answer. You don't always get a simplified answer by using smaller forms of the number 1, but oftentimes you will. Or at least we'll make it out of smaller numbers that are easier to tell what their factors are in order to simplify them. In this next video, I'm going to show you how I had my students write it out by hand, so you have an example and an idea of what students need to do on paper. And it is very important that students write this out on paper. I posted an article, this is the second research article I've seen, that shows that handwriting, there's a deep connection in our society today between handwriting and memory. So if the kids write it out by hand, and the more they write it by hand, the stronger connection to memory they get. This is how I had them do that. I also don't allow students to use a calculator or a multiplication table. They can use a list as shown. This practices their multiples and the process, which is crucial. It isn't glamorous, but it is necessary. As you saw earlier, you can also use the big 1 theory to simplify fractions because multiplying by 1 yields an answer that is equal, but so does dividing by 1, and that's just a different form of the multiplicative identity, because 24 divided by 4 is 6, and 28 divided by 4 is 7. And yes, you can divide straight across. The reason in fractions we do the multiplying by the reciprocal is because it doesn't always divide evenly. If, in this case, I chose it to be divisible by 4 on purpose. In another video, I'm going to show you how to use the big 1 theory to cancel out fractions when you're multiplying fractions. A lot more on those ideas in another video. Thanks for hanging out with me for a while. I'll see you in class.